We're going to look at a couple theorems in lesson 101 that go along with determining lengths of segments, intersecting circles. So right here we have two segments or lines that are intersecting through this circle. And there's two little formulas that we're simply going to use. And the first one is theorem 1011. But if two secant segments are drawn to a circle from an external point, so here's our external point, and remember secant segments are lines that go through the circle. If we have two secant segments that are drawn to a circle from an external point, the products of the length of the secant and that of its external segment is equal to the product of the other secant and its external segment. Long story short, AC, all right, the whole secant from here to here times AB, the external segment, is equal to AE, the secant, times AD, the segment. So putting that into practice, looking at example 1, the external, or the whole secant, now what is the secant? Is the secant 27? And that's where some people might make a mistake. The secant is not 27. From here all the way to here is actually 27 plus 3. It's 30. So 30 times the external segment, 3, is equal to 9 plus x, we talked about how it's the sum of both, times the external x. So make sure the common error will be to just say 27 times 3. That's wrong. It's 27 plus 3. It's the sum of those two to get the whole secant times the external. So 30 times 3, you get 90. We distribute here and get 9x plus x squared. Since I got an x squared, I'm going to go ahead and know that I need to get everything on one side. So I'm going to subtract 90. And what that's going to end up looking like is x squared plus 9x, actually minus 90, equals 0. And then I factor what two numbers multiply to be 90 but add up to be 9. Kind of fast forwarding that, it would be x plus 15 times x minus 6. Because 15 and negative 6 multiply to be negative 90, they add up to be positive 9. So those equal 0. Now from this point, I'm going to move this up here. Okay, from this point, basically you just isolate those and say, okay, x plus 15 equals 0, and then x minus 6 equals 0. So you actually have two answers for x. It can be when you subtract here, you have x equals negative 15, or when you add 6 here, you have x equals 6. Now, since x cannot be a negative number, there's no such thing as a negative length. Like this can't be a negative 3. You don't find that on a ruler. Since it can't be a negative number, that means negative 15 is not an option, so therefore x would equal 6. X equals 6 centimeters. And that's how you do determine lengths of segments with intersecting secants here. One more type of formula. Now let's look at if, okay, we have a secant or, we have one secant. Here's our secant. But now this line, it does not go through the circle. So this is a tangent line. All right. That has a different formula than the one we just did. What happens there is, once again, you take the sum, or you take the whole secant, so AD, okay, AD times AC what that would equal for the tangent would be AB squared. This is your formula. So you would square your tangent rather than, because it's not split into two segments that you can multiply. So let's look at example 3. We already know that our tangent is going to be squared. So I'm going to say x squared equals, okay, what is my secant? My secant, all right, consider this dA, and then C. My secant is dA. dA is not 16. dA is 16 plus 9, so that would be 25. Times the external times 9. 25 times 9 would be 225. Square root it. X equals 15. 15 inches. So that's how you do, that's how you use theorem 101-2. And that's all there is. Just two more formulas to make sure you know.